This is video 2 of our work with logarithmic functions, so hopefully you have already worked through video 1 where we reviewed the idea of inverse functions. And I said that that was important because logarithmic functions are simply inverses of exponential functions, which we've been studying. So we're going to do a little exploration here where we're going to start with the exponential function f of x is equal to 2 to the x, which we have done over and over again. We're going to graph it using at least 5 critical points. So we're going to actually graph some points on a grid, not just a rough sketch. We're going to look at the domain and the range of that. We're going to look at the asymptotes. And then what we're going to do is we're going to graph the inverse of f of x and answer some questions about that. All right, so let's first of all make a table of values for our f of x is equal to 2 to the x. And again, you've done this many times. And so I think we can go through this fairly quickly. So some of the critical values that we've chosen when we've done that is we've usually put in like 0, 1, and 2. Those are nice values. And then also a couple of negatives. So when I sub in the negative 2, of course I get 2 to the negative 2, which is 1/4. 2 to the negative 1, which is 1/2. 2 to the 0, which is 1. 2 to the first, which is 2. 2 squared, which is 4. So if I plot those points, and I've got everything set up for you here, I have negative 2, 1/4. Negative 1, 1/2. 0, 1. 1, 2, 2, 4, and we see that familiar 2 to the x function that looks something like that. Okay. All right, so let's go up and answer a couple of questions about this that we've done before. First, we want the domain. So the domain in interval notation from left to right is negative infinity to infinity. The range is going to be from 0 to infinity. We want the equation of the asymptote. All right, there are no vertical asymptotes for this, but it does have the horizontal asymptote that we have talked about many, many times, which is y equals 0. Okay. And one of the things that I want you to make note of here is note that this one does have a y-intercept. We just said that the y-intercept is 0, 1. We saw it right here. And notice that it has no x-intercept. Okay, so just a couple of things to make note of. All right, so now what it says to do in C is to graph the inverse of f of x. Now, we don't necessarily know what the equation is of the inverse. We're going to talk about that on the next page, but we can still come up with the inverse. So because we know that the inverse, just like we did on the opener, basically takes the x and the y and it reverses them. So if we think of this as our y values right here, we can just reverse these ordered pairs. So if we want to look at f inverse of x, which again, we don't know what the equation is for the moment, but we can still come up with some ordered pairs. So this is our f inverse of x. All right, so we know that f of x maps negative 2 onto 1/4. So that means that f inverse of x has to map 1/4 back onto negative 2. Because this one maps negative 1 onto 1/2, this has to take 1/2 and map it back onto negative 1, and vice versa. F of x maps 0 onto 1, so f inverse has to map 1 back onto 0. This one maps 1 onto 2, so this has to map 2 back onto 1. This one maps 2 onto 4, this one has to map 4 back onto 2. Okay? So notice that this is, at least what we have here, it looks like it is a function. It asks, is the inverse also a function? Well, yes, because we don't have any repetition of x values here, and we're not going to have repetition. So if we think about reversing those, or if we think about graphing these ordered pairs, we have 1/4 negative 2. So 1/4 on the x, negative 2 on the y. And then we've got 1/2 negative 1. So go over 1/2 and down negative 1. We've got 1, 0. 2, 1, and 4, 2. So if I connect those, I end up with, I didn't go up high enough on this one. Should be 4, 2. So right here. So it's going to look something like this. Now what I want you to notice is, notice that this graph over here is getting closer and closer to the x-axis. And so when I reverse it, this is going to get closer and closer to the y-axis. All right, and I know that you know from earlier in the year and from Algebra 2 that basically when you have a function and its inverse, that they are reflections of each other over the line y equals x. All right, so you can see that this point that's right here for, say, the negative 2 1/4, which is here, has its counterpart of 1/4 negative 2 here, right? They are reflections over the line y equals x. The negative 1 1/2, which is here, is going to reverse or flip over to the 1/2 negative 1. Those are reflections over the or the line y equals x. These are reflections over the line y equals x. These are reflections, all the way down the line. Okay, so that's what we call the inverse. Now, let's go back and answer the questions here. So what I want you to notice here is that the domain of this one, remember domain is we're looking at it from left to right. There is no left, it doesn't go over here into the negatives. But this graph goes all the way up close to x equals 0, but it doesn't touch it. So that means that the domain of this one is going to be 0 to infinity. Okay, left to right. Left is this line. There is no right. The range is, remember, bottom to top. So on this one, this goes down forever right here. Just like this goes on forever here, this goes on forever also. So as far as the range, there's no bottom and there's no top because this goes up forever. So this is going to be negative infinity to infinity. So one of the things that I want you to notice is remember that when you have an inverse function, you're reversing the ordered pairs. You're reversing the x and the y values. Well, hopefully it's not a big surprise that the domain and the range flip. So the domain, what used to be the x values, once you reverse the ordered pairs, those become the y values. And then for the original function, the range values, which are the y values, get flipped up into being x values. So we can see that the domain of the logarithmic function is 0 to infinity. All right, so I also want you to notice on this one, just to kind of parallel this, that when you look at these two right here, so the logarithmic function, that this one has an x-intercept of 1, 0. So x-intercept is 1, 0, which again is the reverse of the y-intercept here. And this one has no y-intercept. So no y-intercept. So notice everything about these functions gets reversed, all right? This one has no x-intercept. Whoops. This one has no y-intercept. Okay, so then the last questions here, and it says state the equations of any horizontal asymptotes. Well, this particular function right here has no horizontal asymptotes, but it does have a vertical asymptote of x equals 0. So this is none and x equals 0. And I just want to point out again that this is kind of the reverse. As far as horizontal, as far as asymptote, this one has none for vertical, this one has none for horizontal. And then this one has y equals 0 for horizontal. This one becomes vertical is x equals 0. So just sort of a correlation here. All right. So remember that our big question that we are kind of what's left looming is what is the equation for f inverse of x? All right, and that's what we're going to look at on the next page.